Okay, this is part 2 of the dispersion investigation. In the number 1 here, we're looking at the frequency histogram that was at the top of the spreadsheet you were working with on part 1. This is the teacher distribution, the one that says fill on it. So if you want to, you could just copy down the answers from that, or you could refigure out everything. Okay, so it says using the histogram above, figure out how many students there are in total. Well, each one of these blocks is a student, so you can count up all these blocks, and then you'll figure out how many students there are that got scores between 1 and 50. Okay, and so if you count all these up, you'll find out that there's 23 students. So let's put that there were 23 students. 23. Okay. And then it says, what is the median or middle score? Now, how could you figure that out? Well, remember, to find the middle score, what you do is you take 23, add 1, you get 24, and then you divide by 2, which is going to be 12. And so the 12th score, I call that the index. The index of 12 is going to let you find the middle score. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're counting the block starting from the left side, and we count the 12th block. The 12th block happens to be over the score of 20. So the median score is 20. You might say, why didn't I just take the 23 and divide by 2, and that would give me the middle number, the middle index, to find the median score? Well, think about it. If you have an odd number of scores, then the middle score should be right on one of the index of the whole number, right? When you divide 23 by 2, you end up getting 11.5, which is not a whole number index. So, well, if you take the time to count out the blocks, you'll see that the middle block between the first block and the 23rd block is actually the 12th block. When you have an odd number of scores, the middle score is going to be exactly on one of the blocks. Now, on the other hand, if you have a even number of scores, like 24, then there is no middle block, right? The middle block would be between the 12th and the 13th block. So to make everything work out right, you need to add 1 to the total number of scores or people or data, and then divide by 2 in order to find the median. Okay, so why don't you take a small sample with like 6 samples or 7 samples, and then you could see that to make that work out right, you need to add 1 to the n value before you divide by 2 to get the median. Okay, and you need to do the same thing when you do the first quartile, the lower quartile, the upper quartile. Okay, so when you find Q1, which is the lower quartile score, the score that is 25% of the way from the left to the middle, what you're going to do is you're going to take 23 plus 1, get 24, and then you're going to multiply that times 1/4. And 23 plus 1 is 24, multiplied by 1/4 is 6. So we're looking for the 6th block. 1, 2, 3, 4, 5, 6. So the 6th block is at data 14. So I'm going to write 14 for the first quartile. And then the third quartile, the upper quartile score, is going to be 3/4 of the way from the left. So I'm going to do 23 plus 1. It's 24. Multiply that times 3/4, and that's going to give me the 18th block. So I'm going to count over to the 18th block. This will be 12, 13, 14, 15, 16, 17, 18. So the 18th block is right there. It's above data 30. So I'm going to put 30 here. Now I have the upper quartile. I have the lower quartile. So the Iqr, the interquartile range, what it does is it figures out where the middle 50% of the data is, because it wants to ignore the 25% on the left and the 25% on the right. It wants to concentrate on the middle core. So it's going to take the largest value in the middle core to subtract the smallest value of the middle core. It's like a mini range. Instead of the range, which counts from the maximum value to the minimum value, the Iqr counts the maximum value of the middle 50% and subtracts out the lower value of the middle 50%. So it's going to be 30 minus 14, which is going to give us 60. Okay, 30 minus 14 equals 60. Okay. Then it says, using the histogram, figure out how many students scored 26 or less. Okay, so that's easy to do, right? 26 is here, and so how many students scored less than 26? Well, it would be like 12, 13, 14 students, right? I just counted, I counted the people that got 20 or below, that would be 12, 13, 14, and so that's 14 people that got less than 26, right? Using the histogram, figure out how many students scored 29 or more. So 29 or more, 29 is here, so that'd be 1, 2, 3, 4, 5, 6, 7. So that would be 70. Okay. Let me just erase this extra line here. All right. How did you perform these tests? Well, I didn't do anything fancy. I just counted blocks, right? I counted blocks. All right. Now we're going to figure out a better way to figure out answers to questions like that. Saying, oh, how many people got this or less? How many people got this or more? And the way we do that is with a special kind of table or graph called a cumulative frequency graph or cumulative frequency table. Right here I have a cumulative frequency table. And what you can see with the cumulative frequency table is it's got 3 rows, or it could have 3 columns also. And the top column is basically all the scores from 1 through 50. The second column, you can see that it shows the number of people that got each score. So like, for example, how many people got 12? 2 people, so it says 2 here. How many people got 21? 1 person, so it says 1. Okay? And then you look at the last row, and what you can see from the last row is that basically the last row is like a running count of how many people got the scores going from left to right. So like, for example, here, up to here, there's 0 people that got any of these scores from 1 through 11, so we put 0. People who got 12 is 2. Then, like, you see, people got 13, there's 3. And instead of just putting writing 3 here, we're going to do 3 plus 2, and we get 5. And then we put, in the next one we put 6, and the next one we put 8, and we're adding up the scores. And this is, if you think back to our frequency tables, we did have cumulative frequency tables, which made it easier to find certain data like median, etc. And so that's what we're doing here. We're making a cumulative frequency table. The third row is a running total of how many people got a certain number of scores. So when you get to the last person, the highest score person, which is 35, you can see that it jumps up to 23, which is the total number of people, and for the rest of it, it's just 23. What happens when you graph this? In this graph here, I wrote ungrouped data. Why did I write ungrouped data? Because I'm not making intervals from 0 through 5, 6 through 10, etc. I'm putting everybody in their own single bins, and so you can see that like every time we go from one score to another, we update the cumulative frequency, and we have a lot of little dots here, right? And so this is simply a graph of the third row, okay? And this is what we call a cumulative frequency graph, which is made from a cumulative frequency table. And a cumulative frequency graph always starts from 0 on the left, and then it goes up. It always goes up, never goes down. And then at the very end, it tops out at the number of data points. So in this case, we have 23 data points, so it tops out here. And then we hit the top data point. We hit 23 when we get to the top score, which is 35. Remember, the top score was 35. Okay? All right. It says, oh, I forgot here. Record the small score as the min, the large score is max to be used later in the box and whiskers plot. So the lowest score here is 12, right? And the highest score here is 35. So we're going to record that here. 12 and 35. All right. Then here it says, using the graph, figure out how many students there are total. Well, we might remember that there are 23 students already in the sample, but if we look at this graph, we can see that this max line here, it corresponds to the number of students, 23. Okay, so from the graph, we can easily see that the total is 23 from looking at where this line is. It lies at 23. Okay, moving on to page 2. Okay. Using the graph, figure out how many students scored 26 or less. Okay, how would we do this? We already know that the answer is 14 from our previous block counting. But there's a way to do this with the graph. We can take a line here. We're going to mark 16 because we want to know how many people scored 26 or less, not 16 or less. So we're going to go to 16 or 26. Why do I keep saying 16? And then when I hit the orange line, I'm going to start going left. And this is going to give me the number of people that got that have the score 26 or less. It happens to be 14 people, and that's exactly what we got counting blocks too, except now we did it graphically using these lines. Using the graph, figure out how many students scored 29 or more. So now we're going to do the same thing, except now we're going to draw a line at 29, score 29, and then when we hit the orange line, then we're going to go across, and it's kind of hard to draw this line well, but we can see that it's going to hit the vertical axis at 16. So we know that how many students scored 26, 29 or more. Actually, we can't just write 16 because what it is how many people scored 29 or more. That would be the 16th person all the way to the 23rd person. So actually it's going to be like 23 minus 16, which is about 7. Okay. And then how did you perform each text? In this case, what we did was we drew a vertical line at the score number, at the score, and then drew a horizontal line to the frequency number, the cumulative frequency number. Okay? And that's how we figured out the index, and once we found the index, we either said, oh, it's 14 people because person number 1 through 14 got a score less than 26, right? Or we count up from 16 to 23, that would be 7 people that got a score from 29 or greater. And then we'll go back and look, and we'll see that that actually matches our answers when we count the blocks. Okay, but it was a little bit easier, a little bit faster to do with the cumulative frequency graph. Okay, so comment if these tasks were easier or quicker using the graph in number 3. Yes, it was quicker than counting blocks. Okay, maybe you don't think so, but like if you had a really big distribution, then this method is much quicker than counting blocks. Okay, and then now we're going to do what we call a grouped frequency table, and this is using the same data as above. What is the difference between a grouped frequency table and a frequency table? And so I'm going to compare number 4 with number 2 here, and you can see that, like, first of all, the frequency table has so many columns, right? It's got 50 columns of data. And if you look at the grouped frequency table, it doesn't have that many columns. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I went from having 50 columns of data to 10 columns of data. And how did I do that? By making groups of 5. So like, for example, instead of going 1, 2, 3, 4, 5, 6, 7, 9, and each one having its own column, I made separate columns for every 5 groups, intervals of 5. So like here, from 0 to 5, I have 0 people. From 5 to 10, I have 0 people. From 10 to 15, I have 8 people. Okay? So you can see that I've grouped people into a larger interval, and in the process, I've made my table simpler, right? So instead of all these little ones and nitpicky numbers here, I've got buckets of intervals of 5, and then I have larger numbers of people here. Now, what's the disadvantage? The disadvantage, of course, is now I have less information, right? Of these 8 people between 10 and 15, how many people got the score 10? How many people got the score 11? I don't know anymore. I've grouped them, okay? So, but in some cases, it's more important to have the data grouped and a little bit quicker to use and a little bit less information than to have all that detail. So that's what we're doing here. All right, and so what does it say here? It says, what 8 scores are counted in the class 10 is less than X is less than or equal to 15? Well, if you look up here, which 8 scores are they? Well, there's 2 12s, there's 3 13s, there's 1 14, and there's 2 15s, right? So we're going to write that down. We're going to say there's 2 12s, there's 2 12s, there's 3 15s, or 3 13s, and 2 12s, 3 13s, 1 14, and 2 15s. 1 14, and 2 15ths. Okay? So those are the scores, those are the 8 scores that are contained in the class 10 or 15, 10 through 15, and we don't know exactly what they got anymore when we reduce it to this format, right? Oh, I'm sorry, into this format, okay? The next step, what we're going to do, we're going to, again, make a cumulative frequency table, but instead of doing a cumulative frequency table with individual scores, we're going to do with the interval of 5. So you can see that the first one is going to be 8, and the maximum value here is less than or equal to 15. The next one is going to be less than or equal to 20, and it's going to be 13, which is 5 plus 8. Now, how does this work? So you see that when we make these intervals of 5, each group has a range 10 to 15, 15 through 20, 20 through 25. But if we start doing a cumulative table, then what we're doing is we're saying, okay, how many people got 15 or less? Well, that would be 8 people, right? How many people got 20 or less? Well, that would be these 8 people plus these 5 people, which would be 13. And now my data marker is less than or equal to 20. So I'm actually saying 0 to 20 is score 13, or 13 people. And so from less than or equal to 25, which would be from 0 to 25, I'm going to count the 8 people here, the 5 people here, and the 1 person here, which is 14 people. So you see how this works? It's just like the cumulative frequency table that we did above, but instead of having individual scores, now we have intervals of 5. Okay? And so maybe you don't understand why we're doing this yet, but at the end, hopefully, I can explain it to you and it'll be clear. How are these cumulative frequency calculated? All I did was I added numbers from left to right. Right? Okay. And now I'm going to graph the cumulative frequency table. And when I graph the cumulative frequency table, I get a grouped data cumulative frequency graph, which looks kind of like the cumulative frequency graph we did before. Here's the orange graph that we did before. If you look at this one, the shape is basically the same. It ends at 23 just like the first one does. It basically goes up, it goes up from the left to the right just like the other one does. What you see is it doesn't have all those little dots, and it doesn't like, look at this. It kind of like, do you see how this is like going up and down? It's not going up and down, but it's like, it's very irregular. And when you group it like this one, everything kind of looks more straight, okay? So that's what we can see with this. Now, we still haven't figured out why this is better, but let's go ahead and answer these questions and maybe we can figure it out. Okay, using this graph, figure out how many students scored 26 or less. So the way you do this is the same way you did the other one. You're going to draw a line at score 26, and then you're going to go up, and you see it hits the line there, and then you're going to draw a horizontal line until you get to the corresponding index number here, the frequency number, which is 15. So how many students scored 26 or less? I would say 15. Okay? Then it says use the graph to figure out how many students scored 29 or more. Just like before, I'm going to draw a vertical line at 29. When I hit the line, I'm going to go to the left, and then I hit the vertical axis at 16. So, and then like how many people actually scored 29 or more? That would be from person number 17 to person number 23. So it would be 23 minus 17, which is going to be 6. And if you remember our answers from the original graph, which is much more precise, it's got more dots on it, it was 14 and 7, right? The old scores were 14 and 7. The old number of people is 14 or 7. This graph, which is less precise, gave us 15 and 6. So are the answers different than the number 3? Yes, they are. They're off by 1 in each case, right? Okay. Total number of scores in this case. How do we see that? Well, we look at the graph. We look to see where it tops out. It tops out at 23. So the last student, the highest scoring student is student 23. So n is still 23. Find the median index, which is n plus 1 divided by 2. So that's going to be 12 again. Okay, now how are we going to find the median from this graph? We already know that the median was 20, but what does the graph tell us the median is? So we're going to, the index we're going to look for, the middle index is 12. So we're going to actually do the opposite of what we've been doing. We've always been looking at the score first, and then using the score to find out the index. Now we're going to do the opposite. We're going to find the middle score. by taking the middle student, which is the number 12 student, and then we're going to draw a horizontal line until it hits the cumulative frequency graph line, and then we go down, and then that's going to tell us that the median score is 19, okay? And then, so we're going to put 19 as the median score that corresponds to the index of 12. Huh, interesting. But didn't we say that the median score was actually 20 and not 19? Okay, so let's just remember that we didn't quite get the same number, okay? Now, find the lower quartile index, which is 1/4 times n plus 1, so 24 times 1/4, which is going to give you 6. And then that's going to give us an index. We're going to draw a horizontal line from 6, hit the line, and then we're going to go down and give us 14. Okay? So that means our Q1 is 14. I don't remember if that's exactly what we got from Q1 before or not. Then we're going to take the upper quartile index, which is 3/4 times 24, and that's going to give us 18. And then we're going to do something similar. We're going to go up to 18. I'm sorry, that's not 18. This is 18. We go to 18, and then we're going to hit this, and then we're going to go down, and that will give us 30. So the Q3 score that corresponds to that index of 18 is 30, right? And then it asks us what's the IQR. Remember, when you find the IQR, you're not subtracting 18 minus 6. You're doing 30 minus 14. Okay, you're subtracting the Q3 score minus the Q1 score. So it's going to give us a 16. Okay? And so we have all new values for median, Q1, Q3, for IQR found using a cumulative frequency graph. Okay? And you see that they're slightly off from the values that we got before. Okay? What was the IQR value that we got using this data? So we got an IQR here of 16. Oh, what do you know? They had 30 minus 14 equals 16. And here we had 30 minus 14 equals 16. So actually this one was exactly the same as before. Okay, so the median was off by 1, but the Q1 and the Q3 were exactly the same, and the IQR was exactly the same. Interesting. Okay, now we're going to do the box and whiskers diagram. So the box and whiskers diagram is basically it looks kind of like this. It reminds me of the Green Lantern movie for some reason. Okay, but anyway, it's sideways, and it's got, you know, the reason why they call it box and whiskers is because it looks like a box, and it looks like it has, like, whiskers or something. Okay, like you know, these things here, it looks like whiskers. They really were stretching there for finding this name to give it a cute name. Okay, so how do you draw a box and whiskers diagram? Well, the first thing you do is you draw the middle line here. This middle line represents the middle number. The middle number is the median. What is the median score? Well, according to the graph in number 6, the median score turns out to be 19, right? So we're going to put the median line at 19. And then these two lines to the left and the right, which form the box, this is the Q1 score and the Q3 score. So what was the Q1 score and what was the Q3 score? Well, it's 30 and 14, right? So 30 was the Q3 score and 14 was the Q1 score. And you see that when you form the box, it's not like a nice symmetrical box. Do you see that the left side of the box is shorter than the right side of the box? Okay, now we're going to draw the whiskers. How far do the whiskers go out? Actually, the whiskers go to the minimum and max score. And the minimum and max score we recorded on a previous page here. Here they are. We recorded the actual minimum and max here, 12 and 35. Okay, and when you do a box and whiskers plot, the actual minimum and max, 12 and 35, are actually the ones that are going to appear on the box and whiskers. So these are the 2 points that are actually accurate in a box and whiskers plot. The other ones are all kind of estimated. Okay? So that's our box and whiskers plot that corresponds to the cumulative frequency graph that we just did. Okay. Now for the rest of this sheet, oh wait a second, did we answer all the questions? Okay, according to the graph in number 6, how many scores do you estimate fall in the box and whiskers interval between min and Q1? Okay, so remember, This score is Q1. This score is Q3. This score is the median score. This is the minimum. This is the maximum. Okay? Now, how many people are in the whole distribution? Now, we've been doing this problem so much, you've already memorized that there's 23 people in this distribution. Okay? So, what is 25% of 23? Well, it's very close to 6 people. Okay? So, if you've divided the distribution into equal groups of people, from the minimum to the maximum value, and you've kind of separated them by drawing these horizontal lines, you know that 25% of the people are here, 25% of the people are here, 25% of the people are here, and 25% of the people are here. Since we know that the number of people total here is 23, which is almost 24, we know that each one of these 4 sections has 6 people in it. Okay? So how many people do you estimate fall between the minimum and Q1 score? 6 people. How many people between Q1 and median? 6 people. How many between the median and Q3? 6 people. How many people between the Q3 and the max? 6 people. So you see that adds up to 24, which is not quite 23. A little bit not right, but that's the way statistics sometimes works. Okay, so basically between 5 and 6 people in each interval. Okay? Now what are you going to do? Now for the rest of the sheet, what you're going to do is you're going to copy your histogram from your Google spreadsheet, so your particular distribution, and you're going to do the exact same kind of analysis. You're going to divide up into intervals. You're going to count how many scores are between each interval, and you see we've grouped the intervals, so it's not going to be like this first one where we had like a bunch of different columns. It's going to be like this one here, where we actually counted every 5 and we grouped everyone. Like, for example, we counted 8 people between 10 and 15. That would be 2 people got 12, 3 people got 13, 1 person got 14, and 2 people got 15. Okay, so you're gonna do that. You're gonna take your histogram from your Google spreadsheet, and then you're going to count up how many people got between these five scores for each bucket. And then you're going to do a cumulative frequency table by adding the numbers from left to right. Okay. Once you do that, you're going to make a group data cumulative frequency graph, just like we did earlier. Okay. And then you're going to answer the same questions as here. And finally, you're going to make a box and whiskers diagram. Okay. And so just to answer the question that I posed earlier, which is, how do you why is it useful to use group data instead of ungrouped data? Basically because when you're doing statistics over thousands and thousands and thousands of data points, it doesn't really matter if you're looking at every single score separately. You're looking for trends. So it helps to group that data together and get like a rough idea, a rough graph. And then what happens then is it makes the graph look much nicer, and the graph ends up looking kind of smooth like this one instead of erratic like this one, because really what you're looking for is the main trend. Okay, and that may be hard to see right now, but maybe when we start working on your IAs, it'll become more clear about why you might want to group the data. Okay, so what you're going to do now is you're going to take your own data distribution and you're going to make a cumulative frequency graph like that one. You're going to make a box and whiskers like that one. Okay, go for it.